I'm here at DAO-Owned. The weather is getting a little bit cloudy, so I have to put the jacket back on. But I'm here with Corver of Obol.
Yeah.
And you guys are building something really cool that I just found out about yesterday. So tell me a little bit, what is Obol and what are you guys doing?
Sure, yeah. So my name is Corver. I'm with Obol. I'm the tech lead, kind of heading up all the Golang backend side development of things. And we are building DVT, which is distributed validator technology, which is kind of like the next evolution of Ethereum staking.
Very cool. And so, like, practically speaking, what does that mean? Because you guys are building some really cool stuff on the cryptography side to like share validator keys, and so like, what's the end goal here?
Yeah, I mean, so normally Ethereum staking, what you basically have a single operator running a validator on a single machine, on a single server. And what we're doing is we're basically splitting that, so you have multiple operators running that validator across multiple machines. And we do it pretty much by taking the key and then splitting it into a BLS threshold signature scheme. Instead of the single validator, you have multiple validators. They all are signing like a normal validator, but they are creating partial signatures. And these partial signatures are then shared and combined and aggregated into the normal signature that's then broadcasted to the beacon chain.
So what's the advantage of doing this? Like for decentralization, how does it improve decentralization? And I think more broadly, like, what does this look like when this starts happening at scale? Like it kind of shifts our whole mental model for how decentralized like consensus works, right?
Yeah, exactly. So just thinking on an individual validator basis, the benefits are like you get high availability, right? So instead of like when your single validator goes down, you're offline. And what we're doing is that it allows, like, if you're running a 3 or 4 cluster or a 5 of 7 or a 6 of 9, you can have 1 or 2 or 3 nodes go down, but the validator is still active.
Okay, so you see this as like individuals, like companies or entities running their validators across several different pieces of infrastructure. So maybe they have some of their servers on Amazon, some of their servers on like bare metal, and they're splitting up their own keys that company owns. Or are you seeing it more as several individual entities sharding their validator keys such that they are sharing the rewards, but also ensuring that those validators never go down? Like, it seems like there's different ways to do this in like different configurations.
Exactly. And the cool thing is all of those use cases are valid.
Okay.
It can be one company saying, well, I want to de-risk my own infrastructure and provide a more robust quality of service to my users or just to myself. It could also be Lido saying, well, instead of me trusting, a bunch of ETH to a single external validator, I'm saying I'm trusting a bunch of ETH to a group of validators. And it can also be home stakers. So I can go and stake with a bunch of other people. We create our own cluster, and we're running our stake across that. So yeah, it's like all like from small to institutional stakers.
And what's the opportunity here to create essentially DAO-owned validator keys? I think this is something that I've been thinking a lot about lately, where a validator key or a set of shards of validator key could be held by a DAO. And I'm thinking about this in the context of having a portion of validator rewards going to funding public infrastructure, things like that. And that works on the, that's fairly easy to do, I think, now on the funding side of things, where the rewards go to say a DAO. But having that infrastructure and the key, right, with the key is really what's quite valuable in this whole thing. Having that key be held by a decentralized entity, I think, is something that isn't achievable right now, or difficulty.
It isn't achievable because in the end, currently, you have that single key, right?
Yeah.
And you're going to have to trust someone with that single key to run your stake. And what you can do now is, using our distributed key generation ceremony, you can generate a bunch of key shares without that root key ever being in existence.
Yeah.
And the DAO can then allocate, 9 people or 15 people from the DAO to each get a key, and they would then stake whatever stake the DAO has.
And I think also, I guess then, say that you had a DAO managing a bunch of different shards, shards of a key, and having delegated those, and maybe let's not use that word, but sort of lended those out to infrastructure providers to run the infrastructure. They could then revoke access if one of those validators were acting maliciously, or
so that's definitely on the roadmap, kind of like cluster reconfiguration. So you can define your cluster with your set of keys, and then you can actually say, well, we're going to rotate this guy out, we're going to rotate this in, we're going to increase the size, decrease the size, and then like the next step coming down on our roadmap is like, what do you do with the rewards? So V1, where we're now, is just kind of like looking at kind of like the validator, the hardware side of the business, if you want to think it like that. Where the software side would come in the sense of like, what do you do with the rewards? And that is obviously on the smart contract layer. And for now, you can just stick it in a Gnosis safe, for example. And then the DAO can decide how they want to distribute the rewards. But what we plan to do is adding a bunch of crypto and maybe some ZK on top, where the cluster would then actually produce proofs of the different participants and their participation ratios. And then you can kind of like programmatically and safely distribute the rewards according to the participation of the individual people.
That's super cool. So we've talked about Ethereum, and I guess you guys are building this out for Ethereum stakers. What are the plans to build this and have it available for other ecosystems like Cosmos? I'm thinking specifically of Cosmos because I run a few validators in Cosmos, and
Look, I mean, for now we're definitely focusing on Ethereum. And all the kind of like beacon chain compatible chains out there, like Gnosis. So that's kind of the short to medium term. We're not going to make any promises about other chains at this point.
But so the fact that so because you mentioned you're building this out using BLS threshold signatures, because Ethereum uses BLS, you'd have to use some other threshold or like multi-party computation system for something like Cosmos that doesn't use BLS. Is that right?
I mean, so the key aspects of our system is basically we can coordinate things in a cluster. We can coordinate what should the peers sign, and we can then aggregate and combine the signatures as they come back in. I think swapping out the actual signature scheme would be quite trivial.
Okay. What does the product actually look like? Like, is it a dashboard? Is it like a bunch of developer tools? Like, how do the clusters come together?
So that's quite interesting. So the final product that actually does this whole thing is it's called Karen, and it's a piece of middleware. It's a server. It's very similar to Geth or one of the beacon chain clients. It's a piece of software that you run on a server. And that is a Go program at this point, and it forms its own peer-to-peer network, and you kind of run it in your validator stack. You would have your Geth node, you would have your beacon node, you would have our Karen node, and then you would have a validator client at the bottom sitting with all the keys. And that forms like the whole cluster across a bunch of machines. But that's the final product. And like you said, how do you define the cluster? And you can think of it kind of like in three steps. The first steps would be to define the cluster, which is like, how many nodes do you want? What is the threshold? Are you doing 3 or 4, or do you actually want a 4 or 4 or something like that? You want to give it a name, and and then you want to identify who's in the cluster, give some identities. So that's the first step, and that's the definition or the define step. And we are building something called the DV Launchpad, which is very similar to the Ethereum 2 Launchpad, which will be a UI and a website where you can go in and you can be the leader, and you'll say, this is what I kind of envision, and you'll define the cluster, and then your peers or the other people in the group will follow a link, and they'll put in their signatures. The output of that whole process is what we call the definition file, and that is going to the second step, which is the lock, which we call as the lock step, and that process is where you actually generate the keys.
Okay.
And that's going to be a bit more secure. And so here you're running a piece of software which we call the DKG, a distributed key generation ceremony, and that's a command line application, and the output of that is everyone has their own keys. And those keys, together with the definition file, you would load into the current software.
Okay. This is super cool. Yeah, I can see like all sorts of applications for this. And there is a peer-to-peer layer that allows all of the different machines to talk to each other. Yeah, that makes sense.
Yeah,
Okay.
yeah, exactly.
Very cool. And so, you've launched already, or
Yeah, I mean we're making good progress. We just finished like our first testnet on Goerli. We had a bunch of our community members running clusters, and it went pretty well. Next steps, we're speaking to some big infrastructure providers, and I think they'll do a couple of test nets. But if everything goes well, Q2 next year, mainnet.
Cool.
Yeah.
All right. Well, it's very exciting, and I'm looking forward to learning more and
awesome.
when you guys launch and everything. Cool. Thanks a lot.
Cool. Thanks.
Thanks.